Good afternoon, thank you. So I discussed today about the key technology enablers for a smart grid from a semiconductor company perspective, which maybe was not common at this conference. Let me introduce briefly who we are. So ST is a global semiconductor supplier. We have more than 14,000 employees worldwide, and we develop, design, produce, and sell our chip worldwide, and we have a very broad range of devices covering many applications, and we have facilities all around the world, including here in India. We have development center, R&D center, sales and marketing office, so we can really support this market even locally. So the outline of my talk is the following. So I'll introduce briefly smart grid with the technology challenges. Then I introduce how our latest technology can cope with these challenges, and I show one experience from the field which is very good for this kind of challenges overcome. Okay, you know that there are many applications in smart grid that are interacting with each other, but in terms of technology enabling, all these applications require smart nodes with energy sensors and pervasive connectivity. What is really important, especially in massive rollout and smart metering rollouts, is also that this kind of technology bring the right return on investment for the big investment that utilities has to do. So that's why we think that in terms of connectivity, power line communication is one of the most suitable because it provides a very low cost of ownership to the utility by exploiting the existing power cables as communication medium, not requiring additional communication networking to be built or not requiring fees to the telecom operators, and provide the right ubiquity for all the smart sensors. So that's why my talk is mainly focused on this power line communication semiconductor technology, where we are also as ST market leader worldwide, having shipped more than 60 million power line communication transceiver for smart metering applications. So the first challenge I want to talk from the technology perspective is the standardization fragmentation. Even if we have done a lot of progress here on power line communication, but still there are some different standards that we can say are competing each other, like meters and more, Prime, and G3, that are also proposing and succeeding in having their technology standardized ITU or SEN-like level. And then we have some fragmentation in terms of band that can be used according to different countries. So we have SEN-like, for example, in Europe, or standard band REB, FCC in the other countries. So that's why, from a technology perspective, it's important to have a very flexible and programmable technology platform that is able to easily switch from one technology to the other, one standard to the other, one band to the other, just by software. So in this case, we save development cost, development time. The second challenge is related to the fact that smart grid nodes may have different system architecture. So we have data concentrators, smart meters, user interface units, smart sensors. So in some nodes you require maybe very high integration to reduce the bill of material cost or size. In other nodes you may require very high system modularity, maybe separate communication module in order to host different multiple communication, multiple connectivities and interchangeable connectivity device. So that's why we basically developed this platform, which is ST Comet. You can see here a block diagram. I don't know if it is readable, but anyway, it's a dual core architecture. So one core is dealing with the real-time process of the power line communication stack, so modulation, the modulation schemes. The other core manage the upper layer of the communication stack and the metering or smart grid node application. Both core are completely programmable, so we have a flash and RAM memory, so by firmware you can have different modulation schemes, different protocols on it, using the same hardware platform. And then we have analog front-end section, so the signal in the power line are properly detected, amplified, to be transmitted on the line with a proper high signal in case of very low impedance in the harsh environment like you can have here in India. And you have also metrology front end to let's say, measure with a very high accuracy voltage, current, and derive all the electrical energy and power quality parameters. So as you can see, this platform can cover the two challenges in the following way. So you see here all the communication standard stack, the major one, G3, IEEE, Prime, and so on. So by firmware, you may have the low layer of the stack on the DSP, and then the upper layer on the Cortex core, which is embedded in the same device. So this platform is suitable for multiple standards implementation, and as ST, we provide certified stack along with the hardware of the chip. The other important thing is that ST Comet cope also with the need of high flexibility and of the platform. So we may have a very high integrated solution. Like this is a single chip, a single phase, a single chip smart meter. So it's just based on ST Comet that can manage the display of the meter, additional interface, communicate through the power line, and even sense the power through its specific peripheral. We may have three-phase systems, so you just need to add a dedicated analog front end on it. We may have even modular system with a meter based on the microcontroller and the meter in front end, and using STCOM reduced version just for the communication modem. But you can think to combine power line communication with the RF, interfacing it with an RF transceiver. So let me just show you briefly an experience from the field that merge all these features, which is Grid. This is a funded program that we made together with Enedis as major coordinator. So Enedis, the French utilities, and we had there even many other important industrial players in the smart grid, like Sagemcom, that will have the speech probably after me, Landis+Gyr, and many other players. So the very important innovation of this smart grid infrastructure was that the capability to create an end-to-end smart grid infrastructure with the capability to communicate through with the PLC from the low voltage network to the medium voltage network directly to the Enedis data center. So it was a completely PLC-based end-to-end system over a network of 35 kilometers in Toulouse city in France. And so all the partners build their components, their products, so meters, concentrator, sensors in the network, and concentrator in the high voltage, all communicating with power line communication. In this case was a power line PLC G3. And you see that we use a different kind of bandwidth, because in Europe, in the low voltage, you need to use Senelec A with a very small bandwidth in low voltage, and FCC band on the FCC. In this case, in FCC, you can even exploit higher data rate, so you can collect all the data coming from the low voltage and convey to the data center. And in the system, ST Comet has been used. Sorry. So ST Comet has been used, and by exploiting its programmability, it could manage either G3 Senelec A in the low voltage network or G3 FCC in the medium voltage network. And also we could exploit it in different smart systems. So it was used in Landis+Gyr meter, in Sagemcom concentrator, Sagemcom medium modem in the medium voltage, Nexans gateways, and sensors. So it was solving, let's say, all these issues that you may have from the technology perspective. So we also reach very good results on this. So we demonstrated it's possible to have a very cost-effective and performing technology that can cope with all these technology challenges. Okay, thank you very much.